Superluminal recession. How galaxies are moving faster than the speed of light. This is a topic of discussion in today's lecture. So, topic is superluminal recession. That means here galaxies are receding from us at a speed which is more than the speed of light. Question is how this is possible. How is this possible? We know that according to special theory of relativity of Einstein, nothing can move faster than the speed of light through space. But here there is a problem with this. Problem is that here the object is not moving, means galaxies. We are talking about galaxies. Galaxies are not moving away from us at a speed which is more than the speed of light. No, not like that. Here what is happening, the space between the galaxies and the Earth is expanding. And the rate of expansion, means if you consider the velocity of the stretching of space, then that is more than the speed of light. And according to special theory of relativity, nothing is mentioned about the space. Nothing is mentioned about the speed or velocity of the space. Okay, in special theory of relativity, what is mentioned is that velocity of objects. Okay, and since here space itself is stretching due to the presence of dark energy, you know that there is a repulsive force acting against the gravitational force or gravitational pull, and due to which expansion occurs. Not only expansion occurs, expansion is taking place with an acceleration. And it was found by using telescope, and according to that, one law is there which is used in cosmology. The name of the law is Hubble's law. According to Hubble's law, the velocity at which a galaxy is moving from us is receding from us. The velocity at which a galaxy is receding from us is proportional to the distance of the galaxy from us. V is directly proportional to d, where v is the velocity of the galaxy and d is the distance of the galaxy from us, means from Earth. Okay, but you just consider here the velocity of the galaxy doesn't mean that the galaxy is moving through the space with velocity v. No. Whenever we are considering this expansion of the space and we are considering the velocity of the space itself, then in that case we are finding the result, like v is proportional to d. Say two objects are there, object A and object B. Both are not moving. They are static. So distance between them is fixed or constant. Now if the space between these two objects A and B is increasing, then what will happen? Effectively we can see that both the objects are moving away from each other. But actually that is not the case. Case is space between the object is stretching. It is expanding. Just consider a few dots on the surface of a balloon, and if you inflate the balloon, so expansion of the balloon occurs. Inflation means expansion of the balloon occurs. So what would you observe in that case? You would observe that the distance between the points are increasing over time. And the same thing is happening here. In case of balloon, dots are not moving away from each other. Since the balloon is expanding, so the space between the dots is increasing or expanding or stretching, and that's why we can say that dots are moving from each other, moving away from each other. Okay, but actually dots are not moving. Here also the same case, galaxies are not moving away from us. Galaxies are not receding from us. Space between the galaxy and the Earth is increasing because space itself is stretching. Okay, and this way you will get one horizon which is named as cosmic event horizon, and beyond which if anything exists, say galaxies exist, then light emitted from those galaxies today won't ever reach to us. Here also, if you make the comparison between the velocity of the expansion of the space and velocity of light, then you would see that velocity of the expansion of space is greater than the velocity of the speed of light, and so light emitted from those galaxies today won't ever reach to us. Maybe billions of years ago, the galaxies were near to Earth as compared to today. So light emitted from those galaxies billions of years ago may reach one day to Earth. But today and beyond today, that means in future, if light is emitted from those galaxies, those lights won't ever reach to us. So those galaxies will remain unobservable to us. That's why there is a concept of observable universe. The limit up to which we can see the universe, we can see the galaxies, stars, etc., is known as observable universe. And beyond that limit, or beyond the cosmic event horizon, maybe many things are existing over there, but light from there will never reach to us. Anyway, the topic was not this. Topic was superluminal recession, and where it was mentioned that galaxies are moving away from us at a speed more than the speed of light. How this was possible? Okay, so you have to focus on the theory of relativity, special theory of relativity of Einstein, where it is mentioned that objects cannot move faster than the speed of light through space, but nothing is mentioned about the speed or velocity of space itself. So here in this case of superluminal recession, space itself is expanding, and for which we are getting that the velocity of space or stretching of space is more than the speed of light. So this way the special theory of relativity is not being violated. Okay, anyway, so this was all about the topic superluminal recession. Okay, so this is the end of this video. Thank you for watching this video.